This is lesson 10.4 comparison test. Students will use the comparison test for convergence and divergence, and we will use the limit comparison test. So the question today is can we determine convergence or divergence for a series by comparing it to a series with a known behavior? Well, how can we do that? That's exactly what we'll talk about today. How do those steps work? What does that process look like? So the first theorem, the comparison test for convergence. If 0 is less than the sequence A, which is less than the sequence B for all of K, and the sum of B converges, then A must also converge. So what does this look like to you? Well, you might have a series where you're plotting the values like this. And so we'll pretend that this is B. The terms of B are going down, and not only do the terms decrease, but the actual sum will converge to some value. We don't know what it is, but it will converge to some value. Let me switch colors here. And then if we have A, which is lower, I wrote N instead of K, but N and K are kind of interchangeable. So if we have something that looks like this, so if we have series B sub n or B sub k, I wrote B sub n and k are interchangeable. And down below, we have A sub n. If that series B sub n converges, then A sub n has no option but to converge. So that sum will kind of press it down or compress it, almost like the squeeze theorem did. So if that higher value decreases, then that lower value must also converge. I said decreases, but it should be converge. Example 1, I want to show below that the series converges. So we are going to substitute some of the values here. This is really 1 over 1 to the first. The second one is 1 over 2 squared, 1 over 3 cubed, and 1 over 4 to the fourth. Dot, dot, dot. And what's that final term? This is 1 over n to the n. We do switch the k for an n when we get out to the end, but if you wrote it as a k, that's okay as well. So what are we going to compare this to? So let's compare. Here's the part that students don't like, and I don't like this part either. We have to make up that series that we're going to compare to. You want it to be something that you can solve. So think geometric series, think p-series, think integral test, something that you can actually solve and is somewhat related to the original. So I'm going to give you this one. And where I got it was right in the textbook, I'm not gonna lie. So this is 1 over 2 to the k. So if I list out these terms, I have 1 over 2 to the first, plus 1 over 2 squared, plus 1 over 2 to the third, plus 1 over 2 to the fourth, dot, 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 1 over 2 to the n. So we want to talk about these two values here. And if we start to think of, what are they equal to? Well, let's evaluate. So the one in the top, this is really your A sub k. This is our B sub k. This is a 1, this is a 1/4, this is a 1/27. This is a 1, 4 times 4 is 16. I think this is, I was gonna say 264. I think it's 196. I think, whatever this one turns out to be. On the bottom, we have 1/2, we have 1/4, we have 1/8, we have 1/16. So which is larger? And I'm going to go through and highlight these. Okay, 1/16 is larger than 1 over 196. 1/8 is larger than 1 over 127. The 1/4 are equal, but then the 1 is larger than 1/2. So this feels a little incorrect, but it's allowed. It works. Because we're talking about the number of terms to infinity, we're talking about an infinite number of terms, it's okay if the rules don't follow for the first couple of terms. And it's written in your textbook in one of the earlier sections that as long as the rules work for the majority of the terms, those first couple don't have to be exact. So while it works for everything else, it does not work for the first term. The first term, A is larger than B, but we really want B to be larger or equal to. So starting with term number 2, until we reach infinity, B is larger than A. So we're allowed to compare. And that's good for us. So now we want to use a test that we know and we're familiar with. So if I look at the series from 1 to infinity of 1 over 2 to the k, well, I could rewrite this. This is a geometric series, 1 over 2 to the k. And you can do a -1 in all of that. Just